Hi everyone, my name is Xiao from Indiana University. Today I will be presenting the paper Understanding Malicious Cross-Library Data Harvesting on Android. This is a joint work between University of Chinese Academy of Science, Indiana University, Purdue University, and Xidian University. I'm the first co-author with Jice Wang. My advisors are Luyi, Xing, and Xiaojing Liao.
Hello everyone, my name is Jice Wang from University of Chinese Academy of Sciences.
In this paper, we discovered a new type of data harvesting libraries which are never reported before. They strategically target the SDK from other vendors also integrated by the same host app. Here we refer SDK as the victim library. The sensitive user data are exposed to those malicious libraries. Here we will show how the malicious libraries in an app steal an app user's Facebook access token and access her Facebook account. Specifically, it takes a few steps. First, it will check whether the Facebook SDK is in the app. If it is, then the malicious libraries will obtain users' Facebook access token and or some other user data. Further, it may use the token to access the user's Facebook account, like Facebook ID, gender, email, page likes, etc. Finally, it will send those secret information out to a remote malicious server. Those malicious behavior are done without users' awareness. Note that in such scenario, the malicious SDK can get data directly from the victim SDK, not necessarily having to fetch data from the victim SDK server. We call this attack cross-library data harvesting, XLDH. As we know, Facebook single sign-on is quite popular. More than 16 of the apps on the Google Play deploy the Facebook login SDK. What's more, XLDH risks affect not only Facebook, but also many other popular SDKs in the mobile apps, such as Twitter, LinkedIn, WeChat, Google. Hence, the risk of such data leakage is significant.
Here we use a real example to explain how those malicious libraries perform data harvesting. Specifically, we inspect an app grocery shopping list, which with 1 million installs on Google Play. It contains both an alias library, one audience, and the Facebook SDK for single sign-on. As shown in the left picture, the class in one audience library is found to invoke Facebook get current access token method using reflection. The return value of the function is the user's Facebook session token. Then we found that the token is used to fetch a user's Facebook profile data, including ID, name, gender, link, and so on. And further, all the data, including the token, are sent out to the server of one audience. We then check whether such a data practice violating the data sharing policies in Facebook TOS. TOS is short for Term of Service, which is an SDK developer document that lays out terms, conditions, requirements associated with the use of a mobile SDK. In finger above, given the statement, don't transfer user data that you receive from us, we extracted the data sharing policy pair here. User data, no third-party access, which indicates that the access token is a restricted data item and it cannot be shared with and transferred to third party. Hence, the one audience library violates the data sharing policy of Facebook SDK. Thus, we flag it as a malicious library. We report our finding to Facebook, and Facebook took it down quickly and sued one audience in August 2020. Challenges of detection. It turns out to be non-trivial to check such compliance between code and policies. First, different from app privacy policies that protect personal information, such as address and contact. which can be identified by existing policy analyzer, such as policies or policy linked. TOS describes the restricted data whose security or privacy implications can only be determined from the context of their usage. Examples include security-critical data, such as password, token, and SDK-specific sensitive data, such as UTD-ID used by Alibaba for identifying user devices, friend data and page-scoped user IDs recorded by Facebook, and education and project information maintained by LinkedIn. More challenging is to recover the data sharing policies from TOS that describes the restrictions on collecting and sharing different data items, which tends to be complicated. For example, Google allows developers to access advertising ID or device ID, but it restricts the collection of those two data items at the same time. It requires developers to abandon users' express consent when share protected Twitter content. The Facebook username and password are not allowed to be sent out to the internet by any party. Previous works. Prior research showed that malicious SDKs could collect users' sensitive data from the host apps and mobile devices, leading to serious privacy leakage due to their wide integration by popular mobile apps. To mitigate the problems, prior research also proposed different fine-grained mechanisms to isolate third-party SDKs. Unfortunately, these methods are hard to be fully adopted by current ecosystem due to different deployment limitations. Different from prior research, our study sheds light on a new type of privacy harvesting channel, the cross-library data harvesting, which is significantly different from prior studies in terms of the diversity of the private data and the complexity in determining their data sharing policies, specific to individual SDKs. We found that although VirusTotal and Google Play are able to detect the libraries collecting data from mobile devices, such as MEI and Contact, they all failed to detect such libraries we found and the apps integrating them, possibly due to the challenges in determining third-party data sharing policies and non-compliance with the policies.
Methodology. In order to find how prevalent those malicious libraries are in the wild, we developed a new automatic methodology to identify those malicious libraries integrated in the real-world apps on the Google Play. We automatically extract those policies from TOS released by the SDK vendors, then analyze the code of each integrated libraries to find out whether it makes any access to the SDK's data in violation of those policies. To this end, we first need to identify the restricted data in the SDK TOS. In our study, we observed that the restricted data is often characterized by a long noun phrase, like Google advertising ID, covered by single or multiple noun phrases in the constituency tree. Hence, we crafted several features based on the constituency passing tree tags for each word, which include a word tag, its parent tag, the left and right sublinks, and the location of the word in the span of the phrase. In this way, we can recognize the restricted data here, members' profile data. For this step is to identify whether a sentence describes a data collection and sharing policy. We first check whether the operation of the sentence is associated with data collection and sharing, like use, collect, transfer, store, etc. After that, we check that the sentence subject is not the victim SDK itself, but the library's developer. We also eliminate the sentence with the first party as subject. For example, this sentence is not the policy statement we target for, as it contains the first subject we. And for this sentence, we identified it as data sharing policy as it contains the collector operation and the subject of this sentence is not the first party. To extract the pair object condition from the policy statements of an SDK TOS, our approach first used a dependency parser to transfer the sentence into a dependency parsing tree, which describes the grammatical connections between different words. Then we will leverage the restricted data object as the node anchors to locate the condition by traversing the parsing tree. Here we identify the sensitive data is members profile data and its condition is have valid consent. Finally, to capture the malicious data harvesting in an app, our tool first identifies closed library calls to find the data gathered by third-party libraries from our co-located SDK. Then we check the compliance of such activities with the SDK data sharing policies. Results. We investigate 1.3 million Google Play apps. We discovered 42 distinct libraries stealthily harvesting data from 16 popular SDKs. It affects more than 19,000 apps with a total of 9 billion downloads. The affected vendors include, but not limited to, Facebook, Google, LinkedIn, Twitter, and WeChat. Our works not only reveal the real-world threat to the personal privacy, but also have serious social implications. There are more than 30 mediums report our findings. We also report our results to the affected vendors like Facebook, Twitter, Google Play, Apple App Store, and etc., who are all extremely serious about this risk, which they are not fully prepared for. What's more, Facebook, Google, and Twitter also award us for our findings. That's it. Thank you for your valuable time. We are here for questions.